Speakers to take their seats on stage and let us begin. The first one, who is the bravest, please come on stage.
Да, да, у вас кликер.
Извините, это же кликер или нет?
Нет, это не кликер, это перевод. Здесь же корейцы будут. Нет, они не на английском будут.
Они на корейском говорят?
Они прекрасно на корейском.
А кликер есть здесь или нет?
Вам передадут сейчас. У нас кликер. Где? Да, следите за ним, пожалуйста.
Да, будет девушка следить.
Хорошо.
Я буду за презентацией отвечать, то, что мы там на...
Отлично. Давайте пока.
In the meantime, all the rest is still coming. We can begin. I can tell you about the history of our section in the beginning. When Russian venture company was preparing for INNOPROM, we've had a very long discussion. What is the topic that we will discuss at this serious industrial forum? And for RVC, the topic of innovations and the topic of industry is one of the main focal points. We've been always interested in it. And today, there are several global innovative projects, the Digital Economy Program and the Digital Initiative Program, and we could not actually pass this topic, but then something unexpected happened. Such a competition to take a seat in this hall was something that we did not expect, and I would like to say that I'm sorry to those experts who we had to reject and we didn't let them sit in the presidium today among these interesting speakers that we have here today. That is why I think that the less I speak, the more we will have to discuss. And now I would like to present our speakers to you. We still no, it looks like we are ready to begin. Everybody's here. Our speakers at our panel discussion state support of industrial innovations. Firstly, with great pleasure, I represent our guests from our partner country, the Republic of Korea, Mr. Ong Won-jung, Vice President of Korea Institute for Advancement of Technology. This is one of the most important organizations in Korea in terms of innovations. And Ms. Keun Ji-chung, she is representing Korea Electronics Technology Institute. And now, our Russian participants. In the first place, Alexei Artomov, First Deputy, Department of Science, Industrial Policy and Business, Moscow. Alexei Borovkov, Vice Rector for Advanced Projects from St. Petersburg, Peter, the Great Polytechnic University. That is indeed so, but this person has a lot of various positions, and he even has 2 badges at this conference. I think that Alexander Brichalov did not come yet. Yes, I am not him. I am his deputy. I represent the government of the Republic of Udmurtia. Kirill Lee, the Director for Innovation Activities, Rosatom Group. Dmitry Pyson, Director of Analytical and Research Center, Roscosmos. Vladimir Pastukhov, General Director, Russian Technology Agency. Alexei Ponomarov, Vice President for Strategy and Industrial Cooperation from Skolkovo Institute of Science and Technology. They also delegated another representative, that is Dmitry Uzhinsky, professor of Skolkovo Institute of Science and Technology. We commence our discussion. We will start with an international view. Russian projects and industrial innovations are not new in the global sense. Many countries are now implementing similar projects. Now, I would like to ask our Korean colleagues to tell us about a Korean experience in terms of supporting innovations. What instruments and what institutions are used to support innovations in Korea? We know well that Korea has a very wide experience in terms of government and business cooperation. Please tell us about your experience. You're welcome.
Thank you, Mr. Mikhail Antonov. I prepared presentation. My presentation is focused on Korea's innovation policies. Okay. This is the outline of my presentation today. I would like to start with a short introduction of Korea evolution, then give you an overview of innovation policy, and finally conclude with CAT activities.
I think that over there, because the computer is over there.
There is a sensor. Okay. What you see on this slide is Namdaemun Gate, Korea's national treasure number 1. If you come to Seoul, I recommend it as one of the must-see landmarks. This is an illustration from the graphic of British weekly newspaper dating back to more than a century ago, the year 1909. What you see in the background is the same Namdaemun Gate and the same road that was disrupted by the roll of first ever motor vehicle to cross the street in old Korea. I believe you get a clear picture of how low our technology development level were at the time. Even worse, Korea was devastated during the Korean War in 1950. At the time, Korea was one of the poorest countries in the world. And then, 2 decades later, on June 6, 1977, the special edition of the Newsweek detailed the rapid export-based growth of the Korean economy. At the time, Korea had already transformed into a developing country with export consisting mainly of radio, calculator, iron bars, clothes, ships, tires, and etc. We will all agree that the contrast with the previous slide is quite sharp. And this is where we are today. As you know, the Korean economy has been growing rapidly based on our major exporting industries, including semiconductor, shipbuilding, display, etc. As of 2017, we ranked first in Innovation Index for 5 years in a row, 5th in ease of doing business, 6th in trade, and 11th in GDP. Now, let me introduce our innovation policies. As you can see on the slide, Korea R&D investment amount have steadily increased over the last more than a decade. In 2016, Korea has invested 66 billion US dollars and ranked the top R&D investor in the world. Since May last year, we have new government as a result of peaceful candle rallies. To overcome low growth rates and existing polarization, we aim to change the economic paradigm. Thus, the vision of realizing sustainable growth economy centering on people was announced. To achieve this, 4 major goals was set: income-led growth, job creation, fair economy, and innovative growth. SNUs are to be nurturing as the growth engines for innovative growth and in response to the fourth industrial revolution. The Korean Ministry of Trade, Industry and Energy is in charge of industry innovation, and it has established the industrial policies related to innovative growth. As a result, 3 strategies and 6 action plans have been created with the objective to make Korea the most innovative countries in the world. The 3 strategies are as follows. Allow me to talk more about the new industries that will be nurtured through the industrial innovation strategy. Korean government selected 5 new strategic industries that will enable us to identify new growth engines, secure our presence in global market. Those 5 industries are electric and autonomous vehicle, bio and health, IoT appliance, semiconductor and displays, and energy. Now, let's move on from Korea Innovation Policies to KIAT, the agency supporting industrial technology innovation. We offer the full variety of programs related to industrial technology innovation. To achieve our vision, we have 6 main functions: industrial technology, policy planning, industry academia cooperation, local industry and mid-tier company support, international technology cooperation, technology commercialization, materials and component development. As a part of which, we manage various programs. As you can see, there are solid ties between the industrial innovation policies in Korea and KIA's programs. Namely, the industrial innovation policy action plans are linked with our programs. By putting R&D funds in various programs, KIAT backs the government innovation policy up. Russia is extremely competitive in basic science such as physics and mathematics and is in possession of original technology in advanced materials, bio, and aviation. Complementary to Korea's cooperative innovation capability and industrial technology, we can jointly identify new growth. To achieve this and to strengthen cooperation between Russia and Korea, commercialization and innovation, KIAT concluded on MOU with RVC on 22nd June, and we look forward to build on this by continuously discussing and enhancing bilateral technology cooperative plans. Thank you.
Thank you. Спасибо, господин Оменджун. Ким Джи Чон, вы добавите что-то?
Ms. Chon, will you add anything?
I'll start. Okay. Good afternoon, everyone. I am Catherine Chung, team leader of Global Cooperation Department at Korea Electronics Technology Institute. KETI is a government-affiliated R&D institute under the Ministry of Trade, Industry, and Energy. Today, I am pleased to attend the RPC Forum here in Yekaterinburg and think about industry technology cooperation between the two countries to share opinions together. And today's topic is The New World by the Fourth Industrial Revolution and Companion in the New World. Okay. First, I'm going to go over the Fourth Industrial Revolution, then show some ideas for cooperation between Russia and Korea. The Industrial Revolution is a social and economic transformation caused by technological innovation, and in the 18th century, the first Industrial Revolution was evolved by the invention of steam engines and spinning machines. In the 19th century, we developed electrical power and established a mass production system by automation, thus experienced the Second Industrial Revolution. And since then, we have experienced the Third Industrial Revolution, which is a combination of information technology and industry. Today, we are facing the Fourth Industrial Revolution that puts together intelligence and information to give machinery a human-like intellectual ability to create new value. The Fourth Industrial Revolution is expected to bring changes to the whole society, economy, and lifestyle of mankind by intelligently connecting and linking all objects, spaces, and people. In other words, it means changes throughout the whole society caused by intelligent technologies such as IT and AI based on Internet of Things, big data, cloud, and so on. The characteristics of the Fourth Industrial Revolution are hyperconnection, hyperintelligence, and disruptive industry. Massive big data is generated as objects and objects. People and people, objects and people are connected and applied to various industries through a high-level analysis using AI technology. IoT, big data, AI technology are being applied to the industry, causing the destruction of rules of the existing industry completely, and new ones are being created accordingly. Next, let's look at IoT, big data, AI, and VR/AR, which are key elements of the Fourth Industrial Revolution, one at a time. First, IoT is an infrastructure that provides new value to human life by collecting and analyzing information generated from objects connected to the Internet. As you can see here in the picture, the number of Internet-connected devices is expected to increase exponentially to 8.1 billion by 2050. Okay. 25, yes. Second, big data refers to large-scale data that is generated in a digital environment. It is large in size, has a short generation cycle, and includes not only numeric data, but also text and image data. Products, services, and processes are expected to produce more data, and how to leverage this data will determine whether the company will win or lose in the market. The amount of data is expected to increase very rapidly, just like the growth curve of IoT devices. This exponential growth in data has facilitated the development of AI, especially deep learning. And also, AI technology will be essential in finding meaningful value from the massive amount of data. Third, AI is a technology that emulates the abilities required for humans when we are thinking and is expected to apply to various industries such as automobiles, manufacturing, and medical services. Now, I would like to talk about how the fourth industrial revolution is changing existing industry. In the case of self-driving cars, the services which can be provided based on technologies such as software, AI, communication, beyond automobile performance are expected to become important competitive factors in the future. In other words, we cannot guarantee that today's automotive powerhouse will be the powerhouse in the future. Therefore, traditional automobile companies such as BMW, Ford, and Hyundai are focusing on developing self-driving cars and smart cars with various IT companies such as Google, Uber, Samsung, etc. Smart factories means moving beyond the level of automation for simple, repetitive tasks and responding to various changes by themselves. In a typical smart factory, which you can see here, the Siemens Hamburg Smart Factory, more than 50 million information is sensed per day. If a problem occurs, the process takes less than a minute to restart and the defect rate is around 0.0012%. In the case of VR/AR, Facebook's CEO Mark Zuckerberg emphasizes that VR will be the next generation platform following mobile devices. For example, if we shared the beauty of Yekaterinburg with text in the past, we are now sharing the pictures and videos, and in the future, we are expected to share the contents using AR/VR. We have looked at the definition of the fourth industrial revolution, the enablers, and its impact on the industry so far. Then what should we, Russia and Korea, do in the area of the fourth industrial revolution? Let's go over the technology cooperation between Russia and Korea, which has been a partnership so far, and look at the fields that have potential for mutual cooperation in the fourth industrial revolution era. Russia has developed fundamental science on the basis of the development of military technology in the former Soviet Union. And Russia has possessed world-class level technologies in physics, materials, chemistry, and high-tech fields such as aerospace, satellite, and machinery optics. Russia was Korea's attractive partner for technology cooperation. Although the number of research institutes and specialists has decreased since the global financial crisis in 2008, having excellent researchers was a strong point of Russian science and technology. From the beginning of year 2000 until the global economic crisis, Korea and Russia have been exchanging and cooperating in various ways, such as information and human resource exchange and joint R&D. The development of Space Center Launchpad, KSLV-1, was conducted through the joint project of Russian and Korean governments. Butker Institute of Nuclear Physics, which is the world's top nuclear physics institute, and Korea's ADT have developed gas chamber type detectors for digital X-ray and applied it to commercialization. In addition, we have developed camera surveillance equipment, fluorescent medical endoscope, photodynamic therapy, and LCD lamp reflector together. In the fourth industrial revolution, in the future, Russia and Korea have the potential to generate synergy in cooperation policy, cooperation fields, and cooperation methods. The Russian government's modernization of economy policy is actively involved in the form of national strategy programs to focus on energy efficiency, medical service, information and communications as priority areas with foreign capital. The South Korean government proposed the concept of cooperation, which is the Nine Bridge, from September 2017, and that is a simultaneous cooperation through the Nine Bridge between Russia and South Korea. IoT, big data, and AI, the core technologies of the fourth industrial revolution, are expected to solve the difficulties such as language and geographical barriers and strengthen future cooperation. So what areas are we focusing on in Korea? Number one, intelligent information. We are supporting and encouraging investment in new AI services linked with various industries such as life safety, medical service, and agriculture industry. Number two is semiconductor and display. We are promoting developing intelligent semiconductors for unmanned vehicles, smart medical care, smart manufacturing, and also technologies for wearable devices, AR/VR displays. Number three, broadcasting, communication, and network. Providing services through 5G utilization and public utility of broadcasting technology, especially preparing for changes in the media environment and developing next-generation communication network technologies such as quantum information communication. Number four, software and contents, which supports the development of value-added software which can be applied to other industries such as self-driving car and smart farm. Number five, Internet of Things, securing ultra-light and ultra-low power IoT technology competitiveness and supporting expansion of blockchain technology application for reliable connection between large-scale objects such as smart home utilization. And number six, big data and cloud. Intelligent technology-based big data analysis and management, personal information protection, and development of services for solving social problems utilizing public big data. And also enhancing the development of edge cloud and distributed cloud technology that can utilize real-time data to maximize the value of collected data. International cooperation can be succeeded if there is a lot of interest and continuous support in the field of common interests through information and human resource exchange. In the future, many countries are developing technologies and securing industrial competitiveness through the cooperation. I strongly hope that we will be able to achieve good results by connecting and putting together the advantages of Russia and Korea. In promoting technology cooperation between the two countries, KETI would like to be able to contribute to the connection and support of Russia's research institutes and companies, especially in the fourth industrial revolution technologies which the Korean government is focusing on. Thank you very much.
Спасибо большое.
Thank you very much. Thank you for an interesting overview, both of Korea's innovative policy and the specific achievements and cooperation opportunities. But I have a question that I would like to address to Mr. Igor Uzhinsky. So the terminology and the dialogue is similar. Roadmaps, strategy, high priority industries, and the same about content, big data, fourth industrial revolution, and so on. But I know that besides your major job in digital modeling and life cycle management for complicated objects, you have your own view of the way the innovative policy is implemented in various industries, and you can share a practical view. Maybe you can share your observations and tell us how Russia is different from the US or Germany. I will try to. Can you hear me? Yes, the microphone is working. Could you please show my slides? I've prepared a few for today. So my background is during about 25 years, I worked in the US, and for the last 21 years, I was working in one of the most high-tech companies in the aviation defense industry that was called Orbital UTK, and now it's part of Northrop Grumman, and it's called Northrop Grumman Innovation Systems. But this company, and I'll talk a little bit about it, this company is not a financial or legal firm. It's a purely manufacturing company, and its business is creating, designing, manufacturing and implementation breakthrough cutting-edge products from various industries, particularly high-tech, space, aviation, defense. I am currently working at Skolkovo Institute of Science and Technology on material development, and this center is called Design of Manufacturing and Materials. When I worked in the US in this company that was called ATK at first, it was very large. Its annual production volume was $6 billion per year. That's about two times more than the whole Russian space industry. And in this company, I was also involved in developing some new technologies, new systems, not related to defense, related to power engineering, alternative power. And of course, we were very much involved in Industry 4.0, and it used to be called Advanced Manufacturing Partnership or Advanced Manufacturing Initiatives. This was a government initiative by the US government focused on creating a certain environment. And I have listed three concepts here. Industry 4.0 concept from Germany. That's where it all began, from Fraunhofer system. You probably heard about this system of R&D institutes for technology. But the essence of this approach from the government was creating digital transformation of product manufacturing and building a shared platform for shifting to the digital economy, making sure that digital technologies were applied as much as possible in all German industries. In the US, the approach was a little different. The US approach was about focusing on the platform exclusively. And this platform was, since it was during the Obama administration, it was based on Illinois University, that's near Chicago. There was this Digital Manufacturing Innovation Institute, and its main task was creating this platform and demonstrating certain specific projects. This platform created there. The ground work for all that was the system created by General Electric called Digital Manufacturing Commons. This was a system that's very similar to Siemens PNL, this whole complex, and this institute is firstly doing some work for the Ministry of Defense. About $60 million was invested there initially. But the most important thing about this whole advanced manufacturing partnership program was that the main task was stimulating investment in all these technologies and systems and making this area of digital manufacturing attractive. And the first example of this Digital Manufacturing Innovation Institute on this platform or within this program, as I've mentioned, the government, the Ministry of Defense invested 60 million in this. So in half a year, a group was created. Excuse me. Let me change the slide. So a group was created that introduced additional investment, $600 million. Largest American companies invested in that to make sure it all operates the way it should. I'm not sure why I cannot change the slides. Okay, I cannot go back, it seems. Oh well. So if we are talking about the Russian concept, firstly, we need to develop markets for digital products and technologies, and we need to develop the technologies themselves. This approach, for example, in the US, it's completely unrealistic because either they are in the market or they are not, and they are created when the economic situation demands it. And sharing technologies that you are creating between companies who are competitors, that just doesn't make any sense. It just cannot happen. So the main thing is the government's efforts were aimed at stimulating firstly the investments and secondly on creating this infrastructure. I have a few illustrations here regarding the benefits of this infrastructure. Unfortunately, I cannot go back to the first slide. So look at this slide, for example. When informational technologies started bringing a result. Sorry, I cannot navigate the slides properly. Informational technologies. A famous economist once said in the 1960s that computers are developing, but they are not useful at all. And this was true until the internet emerged in the 60s. As soon as the infrastructure was created where it became possible to share technologies, and I cannot navigate the presentation at all. We need some tech support here. Please help me navigate my slides. Please put me on slide 3, if possible. I will just tell you what slide to go to then. So here we have informational technologies and the result they yielded. When internet became a driving factor, there was a breakthrough in the number of computer capabilities and so on emerging in the market. Next slide, please. A similar thing happened with power engineering. When distribution networks emerged, energy generation boomed. This is automotive manufacturing. You can see that Ford created mass production of cars, but it only started developing when highways were built in the US. Again, exponential growth. And this is the company where I used to work. As you can see, it manufactures lots of various things that jump, fly, shoot, and so on. And this is not a financial firm, it's a manufacturing company, purely manufacturing company, and within this environment, in our company, an environment was created where we were not just implemented a certain PLM cycle, but it was focused on knowledge concentration and creating a database for a product family. As you can see in this slide, it's all in this cycle, and the system of manufacturing is in the center. ATK produces best composite materials. That's what A350 Airbus model is made of, and F-35 fighter plane composite materials are are fundamental for this whole structure. So materials, and the point is, it's not all built on designing or making a single product, but on creating a family of products that need to be modified and developed annually. This is a general layout of our platform from my previous employer. A platform integrating all functions. This is a large American company. Next slide, please. This is an example. I will not dwell upon it. An example that was approved by the relevant security. This is a comparison of designing two rockets. About 12,000 man-weeks were spent on designing the first rocket up to the testing, and for the second one, 120 man-weeks. So labor productivity for designers increased 100-fold. This is an actual example, and I can talk a lot about it. It's an incredible work, but this was the impact you can expect from implementing these digital technologies in designing a family of product, as I was saying. Next slide, please. So when I came here 2 years ago, we created a lab based on the similar principles. This is our hardware and software complex. On the right, you can see lots of software products without which we couldn't do what I'm going to show next, or just one more minute. And over 4 months, our students designed this unmanned flying vehicle. It's not a regular unmanned flying vehicle. It's launched from a pipe. It unfolds its wings in flight, and then it should be flying at 400 meters at 100 kilometers per hour. We've designed and manufactured it, and now we are doing the testing. This is another example over 2 months, and it's detailed design. 22 students who have never designed airplanes before designed this airplane. It's 32 meters wingspan, and it can stay in the air for months. It has solar panels and a power accumulator. It has been designed in detail. And the last slide, the last thing I wanted to say is we have designed, manufactured, and already delivered to the customer Reshetnovo Design Bureau in Krasnoyarsk. This fully automated complex with software for cellular parts manufacturing. That's a very important material for satellites, and we did it over a year. Wonderful, thank you.
You had an overview on various innovations of different countries, and now you're advertising your center at Skoltech, so I think this is enough for you. Actually, I finished already. There is no national particulars, actually. You can apply everything, and then you can have everything right here and now, not waiting for anything. That is great indeed. I now would like the corporations to participate in our discussion. You have a very interesting situation. You are the major producers of innovations, but you are the major customers for innovations. Roscosmos and Rosatom are also the regulators in the industry, and you are participating in a lot of processes, including in digital economy process. Considering this interesting situation that you have, let's look at what the government is doing, can be doing, and should be doing to implement innovations in large corporations and to shift to new technological levels. Kirill, we start with you. Thank you very much. In fact, digital economy is a mega trend in Russia. A lot of companies are working on it. We discussed this already. Companies need to understand what they want to sell in the future. Digital economy has this objective. Now, we try to understand what will be in demand in the future, and then, depending on that future, create our own programs together with the government. One example, Rosatom is responsible for four cross-cutting innovations: big data, new production technologies, quantum technologies, and VR and AR technologies. We understand where to apply these technologies, we know what products are to be launched, and we know the timelines when these are to be produced. How do you think what is going to happen? Your role here as if a government, or are you waiting for the government's reaction to implement all what you've listed? In this context, the government's role is mainly related to the national security, but the civil sector is also a very important one. In civil sector, there is a lot of implementations for medicine, for example. There is lots of implementations for materials, and we are designing the materials that we will use in new reactors that will supply power. We will use them in new products, and they will be utilized in various fields, for example, wind energy. Thank you very much. Dmitry, how about Roscosmos? Thank you very much, Mikhail. You know, Roscosmos is also a unique company from the point of view of converging public and private roles. Roscosmos has a difference. The products and the scope of activity is different, and that leads us to generating public goods rather than market products. When we speak about space exploration and fundamental space science, what we are to understand is that our products are not really generated in the sense of market products. As a state corporation, we are to find the right balance between our commercial efficiency and our commercial activities, our sales and entrance to the market of digital services. But on the other hand, we need to see that there are some goals for the development of science, of space science in particular, in the contribution for education that we are to do, something that is similar to NASA, ESA, and other space agencies. So this balance has to work. Public and economic functions are to work together. We are working on this in particular now. There are a number of tools that orientate towards that. Now I would like to tell you about the toolbox that we have. These are the tools that we use to communicate with the innovative society and also to work according to our activities. That also includes our communication with the outer world. There is some work done together with RVC in terms of our venture fund. We can communicate with the outer world, with the startups, with the medium-sized enterprises. This project maybe is not going as fast as we wanted it to go. We know that it's not very easy to implement venture approaches. Now we're looking to strategic partnerships rather than good financial results. This is a balance between finances and contribution for our product chain. It's one of the tasks for us. And we now have come to an understanding. We welcome international and domestic businesses in terms of how they cooperate with us. We are part of the production process. We welcome the entrance and the emergence of new companies. We welcome the creation of joint ventures. We welcome the mergers and acquisitions. Everything that relates to additive technology, to innovative products. And for example, Alexei Borovkov is one of them who is dealing with these innovations in design. This is something that starts the product chain. But also we like the partnerships that deal with applications that use the results of space activities. For example, bioinformatics. Or it could be navigation, App Store, or other marketplaces online receive space data in order to provide services to regular people. Maybe they are interested in the condition of the environment around them based on satellite images. So we try to look at this, and this is what is happening right now. Another thing, maybe it makes sense to work more with private companies. Even in terms of launch vehicles and spacecraft, maybe that is the next stage for us. We still have to think about it. Now, I want to say that over the past few months, we have come up with several other fundamentals for our activities, including cooperation activities with the private enterprises. There will be a council that will rationalize all the past practices. We will try to adjust our innovative activity alongside with the international trends. We also will create a council for working with the private sector, a public-private partnership council. It will look into how we can work with businesses together. As to digital economy and the program on digital economy, there is a special part related to satellite systems. We are going to develop that area. There is a lot that we have planned within Roscosmos, and there is a lot in terms of digital infrastructure that is to be developed, and digital systems are to contribute to these digital infrastructure units. I think that a number of these decisions will allow us to communicate better with the outer world, and we can understand better what our contribution for innovative ecosystem could be. Thank you. Alexei, large corporations and universities, how big is the involvement between them? Do they work together? And that includes how they communicate within the Center of Excellence project. Thank you very much. Corporations and universities, of course, have a conventional method to cooperate. Universities train staff, and then companies train that staff even further. But there is one other opportunity for engagement, and I think this is a challenge and a problem at the same time. These are very relevant but unresolved problems. And centers of excellence of the National Technological Initiative for cross-cutting innovations are very important. Big data, IoT, industrial internet, all of these are new industrial technologies. This is the most interesting part. Corporations are to emerge, they are to list the most relevant problems that sometimes they hide, but that in any case results in worse competitiveness and in a bad impact on the generation development, and our generation is not as quick to relate to the new technologies. The technologies are becoming more and more knowledge intensive, and this is what is fundamental for the fourth industrial revolution. And our philosopher Piotr Shervitsky said that a revolution is a change of technology of thinking. If we don't change the technology of thinking, we work on something else. The technology that we are discussing is cross-sectional technology. Everything is related to the technology of thinking, and we will see the results in those fields where we prioritize them. That is a mass involvement in the market developments. And of course, what is mostly in priority is designing. Who will make everything smarter, including the problems with the times and costs and everything, including those who will be the fast to create competitive goods and products will be the winners of the competition. What does that actually mean? That is the so-called bestseller of the last couple of years. But actually, it was back in August last year. That is the technology of digital twins, and everybody started to develop this technology. Everybody wants to work on that. Here I have to say that there are digital twins of a particular object, an engine or an aircraft, for example. Then there's a digital twin of manufacturing, for example, casting, welding, rolling, and so on. Then there is everything that refers to logistics, lean production. This was supposed to have been resolved already. If these problems are not resolved, then it means that we are lagging behind the international level. And then there is after-sales service. Here we have digital shadows. Each object has a certain number of sensors. Thanks to IoT, we receive big data, and then thanks to predictive analytics, we optimize the process. Big data is a word that we've mentioned already before. We know that the storage, the protection, and the security of this data is very important in the fourth industrial revolution, but actually we've never mentioned generation of this data. It is very important to generate smart data. The thing is that a gas turbine of General Electric, for example, generates 500 gigabytes of information daily. We can understand how much big data we can actually acquire if we accumulate all the data without actually looking into it. We have a lot of waste data. We need to know what our measures are, what is the information that we're looking for, and that is how we receive a digital twin that we require. We take a look at the design of a structure during all the modes of its operation. And big data actually is something that sensors gathers when something happens. And if nothing happens, there will be no data gathered. It means that we have to know what happens in a particular accident, and it is not widely spoken for some reason. Maybe that is rightly done so. Competitiveness has a direct connection with the digital twins. Who is the fastest with digital twins, and who can understand and describe what can happen with an object during all of its life cycle? And then and those who generate this information will be the winners of the competition. They will be very efficient in cooperating with other countries, and this is the main property of the fourth industrial revolution. And thanks to the National Technology Initiative and its three programs that we have, are the ones that help us to do that. We work on infrastructure, and we also develop the correct technology at the same time. We launch innovative industries and enter new markets. Thank you very much.
And a few more words about TechNet, a working group by RTI. What is it working on? It's about industrial innovations in the general sense. TechNet is the only group that has a specification in brackets, advanced manufacturing technologies. And it's close to Advanced Manufacturing Partnership and Industry 4.0. All cross-industry technologies that are used in all industries. But of course, we are moving towards digital platform solutions. That's very important, what I was just saying. Of course, these are platform-based solutions for new design. When not 500 properties are processed as usual that a designer can keep in mind, but 50,000 properties, and at the output we get solutions that can pass the actual tests from the first time. Of course, we are also involved in smart manufacturing, so in the shop. And we are paying special attention, besides digital and smart factories, we're also paying attention to virtual factories. When we enter this chain of value creation for small, that's a place where small businesses who have limited money and equipment, and they can get into this chain. Of course, when we are talking about global innovative market, when we are talking about markets, we are talking about global markets, and that's very important for the interaction. Thank you. Thank you. And we have listened to the international experience and opinions by corporation and research institutions representatives about the directions where industrial innovations are moving in, and a little less about the role of the government in implementing the support for this dimension. Since we have a good representation in our panel from people who can look at the state support of innovations from the federal and regional perspective. So let's start with the regional track. We have two regions that are probably very different and have no similarities. These are these are regions, Moscow, the largest federal subject by population, with powerful industry of various kinds and lots of R&D institutions. So Now I'm addressing Vladimir. Vladimir, what is the Moscow government's view of their role in creating the innovative infrastructure, and what functions do you think are possible? What tools are you using? Could you say a few words, please? Yes, thank you very much for giving me the floor. My name is Alexey Artemov, Department of Science, Industrial Policy and Business, Moscow. I'm very sorry, Alexey. No problem. That's why I just corrected it. First of all, thank you very much for giving me the floor. It's very useful to share the experience we have gained in the Moscow government's team. Today, as Moscow, based on the results of the previous year, is one of top 50 innovative cities of the world. And currently, the share of companies using innovative technologies and making innovative products is 15%. That's 2 times higher than the country's average. So currently, Moscow is a modern, innovative, high-tech city that plays an important role in creating Industry 4.0. And the Moscow innovative infrastructure includes a large number of facilities like technical parks, and we have 33 of them nowadays, the industrial complex and companies, colleges, youth innovative creativity centers, and much more. We have almost 20,000 such facilities nowadays, and all these facilities are listed on Moscow's innovative portal called iMoscow. And anyone can go there and read about them and establish cooperation links. That's why the mayor reported to the president about the need of creating such cooperation structures like an innovative manufacturing cluster. And our colleagues are now actively working on creating such a cluster. The Moscow government pays a lot of attention to innovations and industry development, and it has developed several dimensions for supporting the companies. Firstly, it's assigning the industrial complex status, and this reduces the tax load by 17%. The next dimension is getting the status of a technical park, and in this case the tax incentives are up to 25%, and the third type is residency in a special economic zone where incentives reach up to 34%. Unfortunately, I am not able to show my presentation because of the time limitations, but I would like to invite everyone to the stand of the Moscow government in the neighboring pavilion, and there we have all the necessary information on each of the dimensions I've mentioned, even a special calculator where you can enter some data and get some suggestions about localizing your manufacturing both in the existing technical park or as a greenfield when you build a new plant from scratch. And these results can also be compared to other cities and other countries. So Moscow, Moscow is really an interesting and beneficial place for creating an innovative manufacturing venue now. Also, we have a Moscow fund of industrial support, and it provides, it gives out loans for manufacturing development at 2%. No bank can afford such conditions on the interest rates. So, as for regulatory legislation, the share of innovative products of 15% must be present in the state contract. The list of innovative products is maintained by Agency for Innovations of the City of Moscow. That's part of our structure, and it uses certain criteria to classify certain products as innovative and include them in this list. I would like to invite you to our stand. If someone is interested, we would be happy to explain in more detail the things I've mentioned now. Thank you very much for your attention. Thank you, Alexei. Mikhail. So the Republic of Udmurtia, the Udmurt Republic, both versions are correct, has many traditional manufacturing venues of defense industry that are that would seem to be outdated, automotive industry and other areas like that. Yet in our RVK rating of quickly growing innovative companies, this list features a couple of Udmurtia companies every year. So could you please share the secret of your success? I would prefer to control the slides myself if possible. First of all, I'd like to thank you on behalf of Mr. Alexander Brechalov, who really wanted to speak here. We were very interested in speaking here, and it's a key session for us. So, Mikhail, thank you very much. Of course, it is my particular pleasure as deputy chairman of the government. It's an honor to speak after Moscow, because it's very nice to talk about opportunities in other regions after Moscow. So just a few words about what's happening in the Republic of Udmurtia and why it is happening this way. By the way, as for the automotive industry, Lada Vesta, the first proper car made in Russia, was manufactured in Udmurtia, in Izhevsk. So the topic is supporting industry and industrial innovations and keeping the region competitive. I'll try to talk about that. Just one slide about Udmurtia and our industry. These are the key facts. We have over 4,000 industrial enterprises, so it's a very industry-intense region, and the significant share of these are processing manufacturing enterprises. You can see we have about 250 large companies, over 500 billion rubles of manufacturing volume. 35% of this is machine building. Let's move on. If we're talking about the key task for the region, its key objective is certainly diversifying our industry. I suppose you know that Udmurtia used to be one of the closed or classified regions. We had classified cities and towns in Russia. A few of them are located nearby, and Udmurtia was a closed region, not available for foreigners and citizens of other places. So for us, switching to civil products is a key task. Even now, it's 17%, which is higher than the Russian average, but we have an even more ambitious goal. At the same time, you can see the manufacturing volume of the defense industry companies, and they manufacture 30 billion rubles worth of civil products. So these are our measurements, and we are actually ahead of the goals. Let's move forward a little bit. Yes, that's right, but at least it looks nice. So, moving to the main task of my presentation, we have 4 simple tools. I'll try to explain them without too much detail. Firstly, we have a trade house of our republic. Secondly, we have contractual output. Thirdly, labor productivity improvement. And fourthly, design. These are 4 dimensions of supporting the industry in our republic. And now let me say a few words about each of them. Labor productivity improvement. We were talking about digital twins. So what are we doing? We are making proposals to other countries or regions that we will make a digital twin for them, and they will see how labor productivity could be improved at their companies. We have a wonderful case study of BFG Group and Kamaz. They made these digital twins and analyzed that the production cycle could be reduced by 1.5 times and labor productivity could be improved by 2 times, reduce lead time and attract additional revenue. Alexei Yevsagin, this wonderful person who is now signing an agreement together with Alexei Borovkov, and he already improved labor productivity for several Russian companies. And as a region that's fighting for labor productivity improvement, let me remind you that we are hosting Kalashnikov concern. When I went to their plant the first time and I saw this shop with cursing workers, and it looked like you enter a drugstore. People were in white clothes, and we are spreading these practices, and that's how we are helping Kamaz, and that's what we can offer to other regions, even to Moscow. So the first tool was labor productivity improvement. Secondly, trading house. Very few regions can package themselves and present themselves. Many people just copy paste text from Microsoft Word to Microsoft PowerPoint, and it's impossible to hear. So we created this structure called Trading House. Its main services are, firstly, packaging. We organize field trips and business missions. Alexander Prichalov was in charge of the Republic for a year, and the export increased 3 times because we're helping to package products, we're helping to make presentation materials, and it is a unique experience that the head of our region made a public promise. He signed 6 agreements with large regional companies, promising to increase their turnover. Just think about it. The head of the region is promising to increase the turnover of businesses. This is not a legally binding contract, but after you've published it, everyone, officials, really start getting nervous. We are sellers in a way, and if we understand that if companies are prospering today, they will pay more taxes tomorrow and ensure more retirement payments the day after tomorrow. So labor productivity improvement number 1 and trading house number 2. You can see it at our stand. Udmurtia could seem a paradise on earth, and it is. But the third story is called contractual output, because the number of venues, you've said that Udmurtia is a very industry-intense region, so we have a lot of space that's underutilized. They exist. You come to Udmurtia and you plug in, and you can manufacture your products at the existing manufacturing venues. That's what China is doing now. Over a week, so you want to make the pilot product from a door handle to a cell phone, and you can do it in a week. We do the same. We make this contractual output. We analyzed over 30 Udmurtian enterprises, identified our strengths, additive technologies, metal working, wood, plastic. So if you want to make a test sample and then organize its manufacturing, you can use the single window system and do it in Udmurtia. And finally, to conclude my presentation, we realized that you can go nowhere without design. That's why we opened this Center of Design Development, industrial design. It's not just about being in trend. It's a real competitiveness improvement tool. We can provide services on designing, and at companies themselves we can develop marketing skills. I can tell you about our company. You go there and you see that the product is cool, incredible, but its design is not great, It's a bit square. sometimes doesn't even have right angles. So if we stay in the same paradigm, it will be hard to sell. That's why we opened the Design Development Center. The key industries are presented here: transportation, and these wonderful. You can see the wonderful images here. In conclusion of my presentation, we also provide services. You understand, it's not just design. You can also do marketing research, documentation, make a test sample. So Udmurtia is becoming this kind of contractor for test or pilot sample manufacturing. You've learned a lot about Udmurtia today. Maybe you didn't know as much before. And on September 19th, you will be able to see it with your own eyes. We are holding a large-scale weapon manufacturers forum, so you can see how we support the industry and what's good in Udmurtia too. Thank you for your attention. Thank you.
Innovations exist not in industries only, but in regional promotion. That is, in fact, a very efficient tool. But there are some instruments that are even more efficient. I speak about regulatory tools now. I ask Alexei Ponomarov to speak on behalf of a working group for innovative technologies. I would like to note in the beginning that everything that we are discussing now leads us to three main values. This is what innovative companies give to the markets. They produce material objects faster and at the same time at a lower cost. Mr. Borovkov and our colleagues from Udmurtia said that already. The second thing, some items can be customized for each particular customer, but without increasing your costs. And the third thing is that you can create something absolutely new. All these three values are to be given to the market. Innovative industrial companies in this case will be successful, but the market is very closed. The regulatory framework is something that impedes this development. You cannot always do these activities, and within the targets of our working group are the targets related to speed and cost. We cannot produce something fast if we cannot obtain a certificate quickly. The main target is to decrease certification timeline by implementing into the certification system the right balance for real and virtual tests. I have to say that virtual tests sometimes are even more reliable than the real tests. This is the first part of what we do. We try to implement new standard procedures. The second part refers to stabilization. Many of you use digital and additive technologies, and you can customize your products. But there is a certificate of compliance that defines what you do and the standard of the previous production times. And you have to customize, but that means you are no longer under the coverage of this old certificate. You have to obtain a new one. If you don't do that, then you are a criminal. And the other task that we do is to change the certification system. so that you can include the customized changes and particulars into your certificates. And actually, the third part that we work on is new materials, an opportunity to use new materials and new items in your products. That is important because that allows you to do something absolutely new. You have new ways of working with your structures, with the actual structures, and you can work in a different way with space aircraft designs and structures. And then we do not actually write the type and the name of your material, but we describe a function of this material. That means that you don't have to stick to metal. If there is a possibility to provide the same functionality, you can use composites. And within this roadmap, we have a number of achievements. On May 28th, changes to the standardization procedures were adopted. They define how to list the requirements, and a new requirement for materials was included. Now you no longer need to write the exact name of material, and that takes away a number of large hurdles were removed whenever you have to say the word metallic. Now standards are being revised. We change where it is needed everything that is consequent to these adaptations. And we hope that within the end of this year, together with the raw standard and Ministry of Industry, we will adopt all the changes. And these changes refer to the modernization of our work with certificates. We understand that these problems are not Russia-specific only. These are global programs. In our working group, we try to enter international certification projects, and we try to promote our conditions, especially where companies are ready to work internationally. About 2 weeks ago, we achieved the first results. We had an international committee of the International Marine Organization, and a new standard was adopted there that referred to the hazardous materials, and all these three elements were included into these new changes that refers to the virtual and real tests and to the materials. And we hope that thanks to our colleagues, we will obtain a Russian and an international standard by the end of the year. We are glad that many companies understand that the standardization market is to be changed, and we are happy that there are leaders who are ready to gather companies around them to shape new methods and techniques for standardization. And we suppose that this is the work that will go on further. This is very important for changing the market of industrial innovations, and then companies can give financial incentives. Thank you very much. We've taken a look at various roles that the government fulfills during the innovation policy. And I have to give the floor to Vladimir to tell about the role of developmental institutions in implementing innovative strategies and policies. What are their tasks and goals, and what are their achievements? Thank you very much, Mikhail. Thank you very much. We have a very interesting discussion. We've taken a look at our our experience and international experience and regional one. So the federal level now is almost done with the federal program for digital economy. This is a targeted program. What will be the main pillars in this program? Where will the state provide its support? The first pillar, which Alexei already mentioned, is regulatory framework. We have to cancel all the impediments that are present. A lot has been done under the leadership of Alexei already. The roadmap has been adopted, and the responsibility for its fulfillment is now on the federal authorities. And the Ministry of Industry and Trade are one of those institutions, and we hope that our work will be supported and we will go even further, and we hope that we will expand our project if we were not able to implement everything in our roadmap from the first time. So the first pillar is regulation. This is what the job of the state is. Then the second pillar, the stimulation of supply. Russian or joint solutions of good quality are to be provided. These are soft solutions, program complexes, so that they would be ready to be adopted in our high-tech industries and for defense and military industries. Private consortiums are being created to that end. We support and work together financially and try to work with the state corporations, for example, with Rosatom, to provide this support, and we work with Rostec as well. They unite a large number of developers that can create highly competitive in the global sense pieces of software solutions, and this is something that is integrated in various digitalization support measures and in support measures for any projects within the Russian Federation. And the third pillar is the demand stimulation. We will promote the implementation of digital technologies. A Kalashnikov was given here as an example, and thanks to the Udmurtia Republic, we found out that the electronic document exchange was born in Udmurtia. Financial instruments are one of these possible tools. And there is also a special program of the government intended to digitize the economy. A company can receive a loan on good conditions, not only to automate but also to digitize completely. The measures and the success indicators are clear, and we understand that loans are an important instrument. And that means that an initiator of this work understands its economic advantages. They take a loan at 1% interest rate per annum, and they perform their projects. And then another thing, we are changing our conventional view towards state investments. Usually, we looked at construction and in technological re-equipment. And now we're looking at implementing and adopting specific engineering innovative solutions. Thank you very much.
Уважаемые участники,
Dear participants of the discussion, dear audience, I'm very grateful to you for expressing this interest to what we are talking about and how we are talking about it. I'd like to summarize it briefly. Unfortunately, there is no time for Q&A, but all the speakers are right here, so if you can come up to any of them and ask your questions. The general summary is as follows. If we could map our today's discussion based on the frequency of the words we used in our conversation, global is probably going to be the most frequently used word. Global competitive advantages, global industry, these are the common dimensions of both manufacturers, consumers, and regulating bodies. If you are global, if you can compete at the highest levels, it means you are innovative. You are applying these innovations in your industry or region or university and institution. And the second frequently used word today was government, and indeed government is multifaceted. It can be viewed from a number of various angles by the industry, and since it's so varied, it has to look for the third frequently used word today, balance. It has to strike a balance and find a consortium. It has to balance resources and tools and opportunities and how to apply its government leverage and authority. Government also has and should and can shape and does shape consortiums to solve large-scale innovative tasks. The Digital Economy Project and the National Technological Initiative Project are such examples. They touch upon the most diverse areas of companies' activities down to the level of every consumer and every person. I suppose we shall finish our discussion at that point. I am very grateful to everyone who found the time and expressed their view, sometimes complementary to what's happening, sometimes not, but that's exactly why such discussion venues are valuable. And I suppose we will be looking forward to new meetings and new discussions. Thank you.